It's quite simple. We take the value of the first digit, which varies between 1 and 5, and encode it in binary on the 3 leftmost bits. The other 2 digits are encoded in binary in the remaining 5 bits. Thus, the famous 404 error will be encoded as follows: 100 for the first 4 and 00100 for the 04. Converting to hexadecimal, we get the value 0x84, which isn't very intuitive. CoAP has taken to encoding this value as 4.04 to indicate that it's a binary representation. For requests, we'll use class 0, which isn't used by notifications. This will allow encoding of request methods get, post, put, etc. There are others that we'll see later. The value 0.00 indicates an empty message. Then we have the version. As in HTTP requests, it appears in CoAP in the first 2 bits, and its value is always 01. To simplify the representation of options instead of using a keyword, CoAP will use a value. In the CoAP header, options must be sorted by increasing value, and we encode the difference between 2 consecutive options. This difference can be 0 if an option is repeated. However, it cannot be negative since options are sorted in ascending order. Since options can be of different sizes, after the delta type, the length of the data in byte is indicated, followed by this data. For example, if we want to make a GET request for the resource hello.txt and we want the result encoded in ASCII, we'll use 2 options URI path, option 11, to encode a URI path element and accept option 17 to indicate the format. For the first one, the delta type is 11 or 0xb in hexadecimal, since it's the first option. The length is 9 for the number of characters in hello.txt. Note that the slash isn't counted, and then we find the characters of the element. Then we encode the accept. We put the difference between 17 and 11, so 6, and the formats are represented by numbers. ASCII text has value 0. So we put a length of 1 followed by a byte at 0. The message ends there. If we had done a post instead, the second option would have been content format instead of accept. The delta type is thus changed to 1 since the content format option is 12. A special delimiter 0xFF would indicate the end of options and the beginning of data, like the empty line in HTTP. The CoAP message is encapsulated in a UDP message. CoAP must defend itself against data loss. It has a special 16-bit field called Message ID. Each new CoAP message will have a different value that will allow it to be identified unambiguously. 4 types of messages are defined. We'll see them soon. Finally, to replace the concept of TCP connections, to allow multiple transactions in succession, CoAP introduced the notion of token, which is found between the main header and option. Since tokens are variable in size, the 4 undefined bits in the mandatory header indicate this length. Now that we've seen the format of CoAP messages, we can detail its functionalities.